Right, we're looking at types of graph here. Now, a linear is where it's y equals x, or mx+c you'll have seen, and then a load of other stuff, so, or 2x or 3x or something like that. They are straight lines. That's a positive one, and I'm going to do the negative ones in blue. Negative ones slope down that way. Okay, so there you go. Y equals mx+c, like I say, you've seen that loads of times before. Right, okay, a quadratic. Now that is where you get, and I'm having to write all over this because I had to squeeze a load of axes in here, y equals x squared and then a load of other stuff. It can be x's and stuff like that, but x squared is the highest power of x, essentially. Now these are called parabolas. A positive one looks something like that. Alright, a negative one, let me change to blue, looks something like that. Okay, the smooth curves, mine's not particularly smooth, but it's the shape of them you need to remember. Okay, so that's y equals x squared, a quadratic. Okay, and you've seen quadratics before, you've solved quadratics and stuff like that. Okay, a cubic, y equals x cubed, and then a whole load of other stuff. Could be x squared, could be x's, and could be sort of plus 4 or whatever at the end. Okay, now they have a particular shape. A positive one looks something like that. Okay, they don't have to have such pronounced sort of humps, as it were, such a pronounced squiggle. All right, maximum and minimums is their official name. All right, or turning points. All right, but they could actually sort of be quite flat, have what's known as a point of inflection. This is a negative one. Oops, that's really badly done. Sorry about that. I went off a bit funny there. So we should go, yeah, about like that. Okay, like I say, you can get them sometimes, and this would be a positive one where it goes flat for a bit and like that. But that is exactly the sort of thing you've got to look out for. Okay, so they're cubics. Y equals x cubed, and then other stuff, basically. Now, a quartic, I thought I'd throw this in there. That would be y equals x to the power 4, and then a whole load of other stuff. Okay, now, you noticed on the cubic, on the quadratic, there was one turning point. On the cubic, there are two turning points. On the quartic, all right, you get two turning points. So it looks a bit like a W. Again, doesn't have to be quite so pronounced. All right, play with stuff like Desmos, free software, and that, and you'll sort of get to know how they work. This is a negative one. There you go. All right, yeah, they won't probably come up in GCSE, but ultimately it's got the same. It's got one less turning point than the highest power of x. That's kind of how that works. Now then, reciprocal graphs. That is where you get something like y equals a number 1 over x, or n over x. I suppose I could put n over x. There we go. All right, now they because you can't divide by 0, they have what's known as asymptotes. Okay, so this is a positive one. There we go. Right, now the graph gets closer and closer to both axes actually here. All right, without actually getting there, and that's partly because you can't divide by 0, and if you divide by anything that isn't 0, you can't get 0, if you know what I mean. So, but again, have a play with stuff there. A negative one is, you probably guessed, in the other two quadrants. So there you go, there's your negative. Okay, and finally the exponential graph. Now, exponentials are where you get something like y equals a being a number to the x. Okay, so the x, the variable, is a power. Now then, this is a positive one. Okay, and they always look like this. Again, you've got an asymptote. I've tried to cross, not that successfully, at the same point here. Now, this point here is 1, because anything to the power 0 is 1. Okay, now if you have y equals 2x plus 3, you move up 3, and so therefore you cross at 4. But it's all to do with to the power of 0 being 1. Okay, they're shapes essentially that you're looking out for, shapes of graph, so just be aware of those.